Hi guys, time for another video. This time I'm going to be doing a video about standard form. So basically, standard form is similar to factored form, and I'll explain why. So the equation for the standard form is y equals ax squared plus bx plus c. So that's the equation for standard form. But the thing that is similar to factored form, because in this one we are still finding the zeros, which are also known as x-intercepts. But the thing that is different is that it's not given to us in the equation. We're going to have to use another equation to find the zeros or the x-intercepts. The equation that we're going to be using is called the quadratic formula. This is a very easy formula and it will help you out a lot. So the formula is negative b plus minus square root of b squared minus 4ac divided by 2a. So now you're going to be wondering why this formula is so big and it might be complicated, but it actually isn't. So let's start off with an example. Let's do h equals to negative 0.2d squared plus 2d plus 0.3. Okay, so this is our example, and let's label the different parts of this. So we know that we have A, B, and C, so let's label it. This will help us out. A is negative 0.2, B is 2, and 0.3 is C. So now let's replace this formula by substitute it by using these numbers. So we first know that we need negative b. So it's going to be b negative. So it's going to be negative 2 plus minus. I'll explain why it's like that after. And square root of b squared, which is 2 squared, minus 4 times a, which is negative 0.2. And c, which is 0.3. Let's extend this line. And this is all divided by 2a, which in our case is negative 0.2. So it's going to be 2 times negative 0.2. So this is very complicated, so let's make it easier by doing everything in the square root, so then we can solve it. Find the zeros. So it's going to be negative 2. This stays the same. Plus minus stays the same. But now we have to do everything in the brackets. So first let's start with multiplying 4 times negative 0.2 and 0.3. So let's do this. 4 times negative 0.2 times 0.3 equals to negative 0.24, and we have to subtract that by 2 squared, which is 4. So let's subtract this by 4, which gives us 4.24. Sorry, I didn't show you. So 4 minus negative 0.24 gives us 4.24. So we know it's going to be the square root of 4.24 divided by 2 times negative 0.2, which we know will be negative 0.4. So now, as you can see, there's a plus minus sign that I've written over here, which basically means we have to we're going to do this equation twice. Once, we're going to add -2 plus the square root of 424 divided by -0.4. And the other time, we're going to be subtracting it, so -2 subtracted by square root of 424 divided by -0.4. So let's do arrows, and then we'll solve it. So let's do one over here, and let's do one over here. So let's do first add it. So it's going to be -2 plus square root of 424 divided by -0.4. And the other time we're going to be subtracting. So it's going to be -2 subtracted by square root of 424, 4.24, divided by -0.4. So over here, we're going to make it easier. So we're first going to find out the square root of 424. So let's do that. Shift square root and 4.24. 4.24, which gives us 2.0591 continued. So let's just write 2.059 in the corner. 0.059. So we know that that's our square root of 424. And we're going to add that once by -2. And then we're going to divide it by 4. So let's do this. -2 plus 2.059 gives us 0.059, and we're going to divide that by -0.4, which gives us 0.1475. So let's round that to 0.15. So 0.15, and it's negative. And the other time we're going to subtract it. So let's do that again. So -2 subtracted by 2.059 gives us -4.059 divided by -0.4, which should give us a positive answer, which is 10.147. So if you round it, it's 10.15. So our zeros are x equals to -0.15 and x equals to 10.15. So now we have our zeros and we can start graphing it. But remember, we still have to find the optimal value and the AOS, which is axis of symmetry. So let's first start with the graph, and we're going to just label these points. It's going to be a very rough graph, as I said before. And I'm going to do it by twos. 2, 4, 6, 8, 10. -2, -4, -6, 8, -10, 2, 4, 6, 8, 10, and -2, -4, -6, -8, -10. Okay, so our x-intercepts, or our zeros, were -0.15, which will be really close to the center, so right there approximately, and 10.15, which is going to be around here. So now we have our 2 points. So now we have to find our AOS, but this time we're going to learn a different trick. Last time we learned r plus s divided by 2 gives us the AOS. This time we're going to use another formula. We're going to be using -b divided by 2 A. So that's our formula. And now we're going to substitute it. So B in our case was 2. So it's going to be negative 2 times 2A. And A was negative 0.2. So we're going to do 2 times negative 0.2, which we already know is negative 0.4. So negative 2 divided by negative 0.4 gives us 5. So our AOS is 5. So 5 is approximately here, and we're just going to do a dashed line so we know that's our AOS. And now we're going to sub in this to our previous equation to find our optimal value, which is our y-intercept, and that's going to give us our vertex as well. So we already know that our vertex is going to be 5, and we still need the y-coordinate. So let's do that. We're going to sub in 5 into our equation. So our equation was h equals to negative 0.2 d squared plus 2d plus 0.3. So now if we sub this in, it's going to be h equals to negative 0.2 5 squared, because remember we're subbing in 5 and there's a squared on the d, so it's going to be 5 squared plus 2 times 5 plus 0.3. So we already know that 5 squared is 25 plus 2 times 5 plus 0.3. So h should equal to, let's do this, negative 0.2 times 25 plus 2 times 5 plus 0.3. This gives us 5.3. So our h value is 5.3. So the vertex should be 5.3. So if we go here and label 5.3, here is a parabola. And let's just draw a line through our points. And there we have it. We have a parabola. And now we can even write this into vertex form because we have all of the important information. So in vertex form, the equation, remember, was y equals x minus h squared plus k. So we have a, which in our case is negative 0.2. So we're going to write y equals to negative 0.2 x minus h, and our h is our 5, because remember AOS is the same as the h value, minus 5 squared plus our k value, in this case, is 5.3. So now we learned from standard form how to convert it into vertex form, and we also learned the different parts. So let's review. The standard form equation is y equals ax squared plus bx plus c. And in this case, it's similar to the factored form equation because in both of them, we're finding the zeros or slash x-intercepts first. But in factored form, the x-intercepts are given to you. In standard form, you have to find it using the specific formula, which is the quadratic formula, which is negative b plus minus b squared minus 4ac divided by 2a. The example that we used, we substituted for it. So negative 0.2 was a, 2 was b, and 0.3 was c. We solved for it and we got our two x-intercepts. Then we plotted them on our graph. To find the AOS, we used a different formula, which was negative b divided by 2a, which gave us 5. So we made AOS on 5. and then we subbed in 5 to find the optimal value. So we sub in to find optimal value. And we got 5.3, so our y coordinate was 5.3, so we found our vertex, and we had all the given information, all the necessary information needed, so we converted it. The vertex form equation was y equals ax minus h squared plus k, and when we substituted it, we knew that the a value never changes, so y equals negative 0.2, x minus 5, because that was our AOS, squared plus 5.3 because that was our optimal value. So there you have it. Thank you for watching. I hope you liked my video.